Good afternoon. My name is Tony Adebonojo, and I am going to be presenting this lightning round talk today on the work that we did in this past year to model the entire United States critical infrastructure, the 16 sectors that Department of Homeland Security has designated are critical to the life and well-being of the United States. I'm going to be going through the agenda that you will see here. And what I'm going to cover in this 18-minute talk, just some of the goals and the context for this project. After, of course, I introduce my team. We're going to talk a little bit of the references used for the data that we have put into our model, and then just kind of show you some of the preliminary artifacts that we created, block diagrams of the 16 sectors, and an example that we have here, and then get into a little bit about what the national critical functions are, and then go into kind of an example decomposition of one of those functions. And then finally, talk about how we have used this data in terms of our interaction with the Department of Homeland Security offices, and some of the future work that we have coming up in the future. And of course, we want to invite you to the working session that we have tomorrow, January 30th in the afternoon. So what I'd like to accomplish in this presentation is basically to show you how we've used the donated software by Desole Systems. They gave us 15 licenses of Cameo Enterprise Architect, a tool that many of us use in our daily paid engagements, to perform function analysis on the DHS provided national critical functions as an innovative use of MBSE tools. I'm going to talk about the impact of this work and the next steps, and then, of course, invite your participation with us. So just to introduce you to the team that has been working on this for the last year, Dan Eisenberg is our work group chair, and he's kind of been providing some steering to this effort, links to DHS and other labs that obviously he works with on a daily basis. Kirk Moen helped us set up our Teamwork Cloud environment and our environment, model environments. And he's, leads a number of SE projects, proposals and things like that for his company. Ken Heck is a retired Boeing employee, and John Uhas, I'm sure that you know from his work in the Power and Energy Group, as well as Howard Likens from the Resilient Hospitals team. And finally, Dr. Vijay Thupral, who's an Indiana University professor. And so what you see here right below that is essentially a block of representing the system of interest that we're going to be talking about. And in particular, in the operations compartment, you'll see the 4 top-level national critical functions: connect, supply, manage, and distribute. And of course, as parts of that block of the 16 sectors that you'll see here on the right-hand side, everything from chemical to healthcare, food, agricultural, energy especially. There's certain lifeline sectors that obviously are very, very important, without which none of this really makes any sense. That is the water, telecommunications, transportation, excuse me. And so those are interdependencies that we have kind of looked at in our work. This is just a list of the references used. All the hyperlinks that you see highlighted go directly to the CISA website, and data stores there that we have consumed in this effort. All the SSPs, the 16 of them you see right here. So a little bit about what we set out to do. Now, I'd actually done a little bit of modeling using some other tools myself of the sectors, and I really became very interested in the depth of detail that was present in the sector-specific plans. And so at the IW, we put forth proposal and got a team of people together who are interested in doing the same thing. The types, for example, that you'll see in some of the sectors, like stadiums as an example, are very rich in threat analysis potential and things like that. So we brought all that data in as draft into the model, but we need a way to vet it, right? Because obviously system models have to be vetted. Certainly we created some interdependency diagrams from that, and you will hear a little bit more about that later on. We started a risk diagram, again, using DHS material. And then finally, the critical functions that we're going to talk about today, we decomposed late in the year, and then, we have a demo of the website. One thing of note is that the infrastructure data taxonomy was something that we found late in the year and helped us to engage with DHS. It's a really rich source of data at or below the level of information in terms of detail that is in the sector-specific plans. And so it's something that we can use to validate our models going forward, but it is a little bit old, circa 2011. This is an eye chart, but as I blow it up, you'll see here a block diagram for one of the 16 sectors. And this just kind of shows us that in the food and agricultural sector, we have, for example, a taxonomy that shows in block form, road transportation of agricultural and food products, rail transportation, maritime transportation, and air transport, obviously linking to the transportation sector. And so this is a rich source of information. Even the terms here of food products obviously encompasses a range of things with a supply chain associated with them, all the way back to farms and fertilizers and things like that. So, excuse me, this just kind of shows the amount of data that we're consuming from the sector-specific plans from DHS. One of the problems that we encountered, though, was the fact that because the definitions here were a little bit large in terms of their scope, it was difficult to do certain types of, shall we say, matrices, dependency matrices, especially with regards to the hospital sector, which is one of the areas that our team was very interested in. We had things like hospital systems as opposed to hospitals, where a hospital is very atomic and very easy. It sits on a defined piece of land with connections to water, power, sewer, and things like that. So you can easily draw dependencies to a hospital, and thousands of them, various types in the United States. But a hospital system is more of a corporate entity, which is a little bit more unwieldy in terms of a dependency diagram or analysis. This just kind of shows the fact that there are 55 NCFs. And so what are the NCFs anyway? Basically, they're the functions of the government and private sector are so vital to the United States that any disruption or corruption or dysfunction in them would have a debilitating effect on the security, economic security, or even the public health or safety, or any combination of thereof in the United States. And so they're very important. They were first mentioned in the National Cybersecurity Strategy under the last administration, talking about the fact that we needed to codify these, assigned to DHS, the way to do that. And of course, they're now being used in executive orders, the first of which was EMP Resiliency Executive Order, circa 2019, and has also been used in responsible use of PNT, as well as securing IT supply chains, again, executive orders that were recently or 2 years ago promulgated. And so, and in fact, in the model, we have these hyperlinked in, so you could click on that block and then go to the actual executive order on the National Cyber Strategy in that external source, DHS source or White House source, whatever. So, and this is just kind of showing some of the unique uses of the model that we have. It's interesting to note that the FCF span the range of being national in scope down to local or even hybrid in nature, and some of them are actually regional as well. So I wanted to kind of talk a little bit about the top level critical functions. First of all, we have the connector, 9 connect SCFs, the 9 distribution SCFs, and the 24 management and 13 supply NCFs. On the right here, you'll see the 24 NCFs for the management category, processes that ensure national security and public health and safety. And so, for example, see things like conduct elections or educate and train. And if particularly note, for example, there is provide funding and liquidity services in the financial sector. So this covers a range of things in United States life. And the four yellow ones are ones that don't map back necessarily to any of the SSPs, because this obviously was data that was promulgated in 2019. So I just wanted to talk a little bit of an example of one particular NCF, excuse me, why it's of interest to us. The words maintain and operate in the systems engineering context have very interesting meanings when it comes to looking at the entire V, or the latter half, where we operate a built system for 20, 30 years. It might be a hospital, might be a power plant. And the fact that this is communicating that the critical function is to maintain as well as operate those core networks, right? Now, maintenance obviously implies a certain skill set that is different from those who operate, right? And this speaks to the actors and skills that are required to maintain and operate a system. So I just wanted to point that out, and it's kind of thing that we'll see when we get into our decomposition going down into the model. And I'll get into the model in a second. This just shows that there is a one-to-many relationship between each function and the SSP data in almost all cases. There are a few exceptions. And obviously outside the model, as you see here, the infrastructure data taxonomy, which I will show you a glimpse of later on, can help us validate that SSP data. It's very, very rich, even deeper, and it kind of mirrors this NCF taxonomy here, where you have segments, subsegments, and assets at the very bottom with very detailed descriptions in the IDT, which is perfect for validating our data here. Obviously, the NCFs are being used for macro level analysis of 5G, PNT, as I mentioned before. And I just wanted to show that NCF graphic from DHS because it's very helpful in understanding that one NCF obviously will map to a subfunction, more than one subfunction, excuse me. But that subfunction may be fulfilled by multiple systems and then assets down the tree. Excuse me. I'm going to get into our model here and just kind of walk through this mini splash page that we have and show you a little bit of our decomposition. So let me do that right now. Okay, what you're seeing here is an output from our Cameo in showing a splash page for specifically the NCFs. So this is showing the 9 Connect NCFs that we were working with, and Ken Heck did a lot of this work for us with the definitions on the row, the second row here. So this is the point where we started for our decomposition effort. And I'm just going to go through this a little bit quickly in the interest of time. This view in the model kind of shows all 16 sectors, but two views of it. In particular, the communication sector that is the subject of the analysis that we're doing of the critical function. And now here, this graphic kind of shows the fact that there is number 1, Connect NCF, and that's the text of it, maintain and operate communication backbone infrastructure for voice, video, data transmission to end users through broadcast cable, very different in situ types of capabilities, right? So cable networks are very different than wireless or even broadcast TVs and things like that. And so here we use functional requirements to kind of begin to parse out using shall statements, always as we do with requirements, this one particular function. And then obviously the design constraints on the right there. One of the things that you'll notice is that when they wrote their functions, obviously they are not necessarily atomic in nature, and they're very ripe for this kind of decomposition. So, and this is the kind of thing that we obviously want to engage with DHS on. I'm sorry. So this is kind of the full-blown decomposition. We have activities which are really the best types of entities in SysML to use for functions. excuse me, this is not here, not UAF. But so we see here we have a managed communication, a backward infrastructure, operates and then maintain, right? So maintenance, obviously, patching from a cyber perspective, things like that, being refined by functional requirements that are kind of doing the same thing, and then obviously being satisfied by the logical entities or breakdown from the communication sector with a design constraint there as well. Below this, my source of interest has to do with the market analysis and things like that you could do. For example, there's over 15,000 radio stations in the United States borders of the AM, FM variety, which obviously are operating today. And so that kind of analysis, especially when it comes to SCADA systems and other types of things, is very rich in terms of what we as system engineers and cybersecurity professionals can do to analyze these critical functions at the lower level. And so I'm going to go back to my slideshow here and just kind of finish out the briefing. And so you saw these slides earlier. So on the right here, you see the block, the functional requirement block that kind of shows the pieces of information, cable network access, radio network access, wireline. Now, in terms of, for example, satellite network access, here, if we conducted design synthesis, you typically find there are people, processes, and technology that are things that, as we go through trades, we will come up with, right? Satellite ground stations, people, and things like that, with skills and whatever. The IDT kind of mirrors that. It's a separate data store, older data store, but you see here also satellite ground stations, satellites, which is obviously a very expensive thing in the sky, and then the satellite operations center. This last chart just kind of shows the IDT, and I'm just not going to spend too much time on it. You'll see the definitions at the bottom here. For example, facilities involved in supplying coal. This is from the energy sector, right? But it's a facility, and it's very specific as to what it's doing. This is a great source of information, as I mentioned, for kind of validating the models that we have from the SSP data, strengthen our DHS modeling effort. And so finally, I just want to invite you to tomorrow's meeting, starting at 10 a.m. Pacific time. Carmen Zapata, who is our DHS contact, is going to be giving a talk along with Idaho National Lab and Lawrence Livermore. And then our team is going to be presenting our model work, including myself, at 15:30. And so you'll see here the information to access a Zoom meeting to kind of join us and listen in on those talks and discussions. And so finally, for future efforts, we do have some model sustainment, that is cleanup, and some work we need to do to kind of straighten things out of the model. We were aiming specifically to get at the dependencies across sectors. And so we really just started bringing data into the model. So we're going to back up and maybe look at use cases and things like that, and other ways of terms of, making sure that the model is sustainable over the long haul. Certainly the glossary was something that was very useful when we talked to a DHS. They looked at it as indicative of how to do an impact assessment on changes to the enterprise, the DHS enterprise. And so I was quite shocked that brought one of the biggest smiles to the face of Carmen when we showed that to her. Certainly, things like being a trusted advisor to the DHS is in the realm of possibility. And one thing that was interesting, the IDT didn't have cyber represented in it in 2011 because cyber was not a thing back then. And so there's an opportunity to begin to bring cyber into the IDT, and people like system engineers, especially with cyber background, from other working groups, in fact, might be very helpful in working with DHS in that process. And so finally, this is just a graphic that DHS has put out on their website to help people with SCADA system problems and things like that, look at the architecture and assets involved and that kind of thing. And I want to thank everyone for listening to this talk. And I hope to see you tomorrow at our meeting. Take care and bye-bye. God bless.